This is Kosmographia, the Randall Carlson podcast. And welcome back, ladies and gentlemen, to Kosmographia, the Randall Carlson podcast. I am Russ.
And I'm Kyle. How's it going?
And we are joined, as usual, by Brad. Brad, how you doing, sir? What's going on this week?
Evening, gentlemen. I'm really good. Made a trip to Atlanta, but I'm back in North Carolina now, so catching up and actually doing pretty good. Thanks.
Yeah, you make. How often do you do that trip? You go down there quite often, don't you?
Well, not as often as I used to. It'd be every other week sometimes, depending on the workload down there. But I'm spending a lot of time editing Kosmographia podcasts these days. So it's like once a month or once every 6 weeks now.
Right on.
But yeah, Mike? I got to meet up with Mike, meet up with Randall, get things done. And this last trip was finalizing some of the things. I know we've been talking about it for 6 weeks, but the website, randallcarlson.com, is so dang close. So we had another half dozen things on the list, and we stayed up till couple nights in a row till 2, knocking stuff out. So hopefully, maybe by the time this comes out, we'll be rocking randallcarlson.com.
All right.
Yeah, that would be great.
Mike, sir.
Howdy, guys. Everything's
How you doing?
fine here in Atlanta. It's incredibly hot.
Yeah. Yeah, you got a little shiny there.
Yeah.
The shiny rose.
What can I tell you? The makeup girl skipped out today.
And Randall,
yes,
sir,
sir.
How you doing?
Russ.
I know your AC is going out. Is that also happening at your
place?
place?
The compressor's going out.
Man,
it's 15 years old, but so we got a new one going in tomorrow, which is great.
So I know we got a bunch more interesting stuff to talk about today, but first I want to ask more questions about this Jeremy guy. And people have been asking about this, right? So,
ordinarily now, I mean, we can make an exception, but ordinarily we don't talk about Jeremy.
Oh,
but
this is a secret.
I said we could make an exception.
Okay.
Because, I don't know. What is there to say about Jeremy?
Well, let's.
He's quite a guy. I think.
Yeah,
I was gonna email him and warn him. I'm hoping he's still reachable, but I'm not sure. I haven't heard from him about a year now.
Warn him. People are looking for you now, bro.
Yes. You're a celebrity now.
You have been cited.
That's right.
Yeah. So that's what I was thinking. I should show a picture here so people can kind of get the impression. And that way, if people know what he looks like, then they can make reports. We'll start at we'll just establish a log and we'll just keep track of Jeremy sightings.
Right. We can have a place on the randallcarlson.com for Jeremy sightings.
Yeah.
Right.
There we go. Because
but he was into sacred geometry. He traveled with you guys. And then what happened? He just decided, I'm going to go look for Sasquatch. See you later. Was he always interested in cryptids, or did this
he was already very interested at the time we met.
Okay.
Yeah. I mean, I guess we hung out for 20 years.
Yeah,
we were good friends. He had a very wry sense of humor, and it was subtle, so that a lot of his humor went over people's heads, but it was hilarious if you got it.
Yeah, classic punster.
Yeah. And he was an artisan. You guys said he was a very skilled craftsman.
Yes.
Is that right?
He was a stone worker.
By
craft.
Right.
And so he and I went on many stone quests where we would go
looking for a particular kind of stone.
Yes.
Yeah.
Throughout the southern Appalachians, hiking up creeks, hauling out 5-gallon buckets of stone. loading up in his van, and then he would make all kinds of artifacts. Brad, do you have that that lamp that you pulled out the other day? Is that handy?
I could get that. Yeah.
That was
take a look at that.
I would. I'd like to see
take
that.
a minute to plug it in. I don't know if I could really demonstrate its use, but yeah, I can grab that. I was going to say he came up. Yeah, okay. You pull up a picture there, but he came up a couple episodes ago. Also, not just with the Boulder field, but the first time you went to South Georgia and flew over Carolina Bays that are in Georgia, he was with you for that.
Yes, he was up in the
early 90s. So
yeah, that was about 91 or something. Yeah, he was up in the plane with me, flying over Georgia Bays. He sure was. Well, yeah, that was some of the early excursions that we took to learn about the bays, because there's quite a few bays in southern Georgia.
Yeah.
What's interesting though is that they are not nearly as eccentric as the bays in the Carolinas. And their axis is oriented different. Their axis, where the axes of the bays in North and South Carolina tend to be more northwest, the axes of the Georgia bays tend to be more north-south.
Right.
Which does fit that the splayed pattern.
Right.
It does. It fits the splayed pattern. And I realized that way back then, but of course, at that time, I knew nothing about the Nebraska depression.
Right on the other side of the pattern, yeah.
On the other side of the pattern, yeah. I didn't know about that until, I guess I don't know if it was Tony Zamora it was probably Tony Zamora. His work that I first heard of Nebraska, because I was obsessed with the bays for a while, and at some point realized, well, man, I just don't know. I mean, I went through, there was Henry Savage's book that came out in 1983, The Mysterious Carolina Bays. And one of the things that he attempted to do was to make at least one reference to pretty much every single thing that had been written on the bays up to that point, 1983. So he had a very extensive bibliography. And so I used that bibliography. I got the book probably and read it probably late 80s, 87, 88, something like that. Got it at the library, because not far from where I live here, DeKalb County has a science center that's been around and affiliated with the DeKalb County schools. But they had they've got a planetarium there, they've got an observatory, and they had a really good science library. So I had discovered that, and it was set up for basically anybody to use, public or whatever. And I went in there, and by repeated visits, I got to know the head librarian very well, and she got very interested in what I was doing. And so they had interlibrary loan capabilities to several hundred universities. So I was able to start collecting all of this really, really rich stuff about 88, 89, 90. So I got Henry Savage's book, The Mysterious Carolina Bays, and got the bibliography and tracked down just about every single paper that he referenced in there, and then methodically set out to read every single one. Then I went, made several excursions to South Georgia in order to investigate bays firsthand. And there was this was actually about before I did a couple of years of geology studies at Perimeter College. This was just before. So it was probably 90, 91. And at one point, Jeremy and myself went down there and went to a little rural airport and found a pilot. And I don't know, probably gave him $50 or something. And he flew us up and flew us over some of these bays. And we can actually talk about it. I have photographs that I took, although as we're up there, it started raining and storming. And so, kind of screwed me up. The light was getting bad. So, but you can still see, I mean, they look very crater-like. They actually look more crater-like in Georgia than they do in the Carolinas because of the fact that they're rounder. But, so old Jeremy, he was interested in that too, and interested enough that he and I went there together. And on a couple occasions, I went down with Ed Albin, who was at the time getting his PhD, and he already had his PhD in anthropology. no, I'm sorry, back up, astronomy. And he was getting a second PhD in geochemistry. And so he and I made 2 or 3 trips down to South Georgia, collecting trips to bay rims. And I do remember interesting, and what he was actually looking for, though, was the Eocene Oligocene exposure just south of Macon, Georgia, because the Eocene landscape was the landscape that had the rain of tektites from the Chesapeake Bay impact about 35 million years ago, right at the boundary of the Eocene transitioned into the Oligocene. So a lot of those tektites from that big impact in what is now Chesapeake Bay, the material, of course, went up and splattered back down. And as it's descending through the atmosphere, it's cooling and taking on a variety of aerodynamic shapes, falls on the landscape. Now, 35 million years, that landscape is generally 20, 30, 40 feet below sediment, later Piedmont sediment that was over it. But right at the fall line, south of Macon, there's a drop-off. And so that boundary is exposed in this drop-off, the fall line it's called, which actually stretches for hundreds of miles. And it's a change in elevation because what it actually represents is an ancient shoreline at the point when sea level had risen that far. This is way back, though. So what you would do is you go down there, and I haven't done this in years, but it was a lot of fun to do. You go down there after heavy rain.
Yeah.
And then you walk that strata looking for that, trying to keep, and it's a very distinct clay layer at the Eocene Oligocene boundary. And so you'd look for tektites that had washed out. And there's a whole collection over at the Fernbank Museum of Georgiites, they're called, Georgia tektites, 35 million years old, and it was the splash from the impact. So he was actually looking for those. And he'd been going down there collecting tektites for display in the museum there. And somehow somebody said, well, Randall Carlson has been in the library for a couple of months doing research on the Carolina Bays. So he came in and introduced himself and said he was interested in them too, but hadn't really gone to see any of them. And I hadn't at that point, I don't think. So we made the agreement that we would go down there. We would walk the Eocene Oligocene boundary looking for tektites. And then right in that area south of there, like down by Tifton and that area of central South Georgia, there's a whole collection of bay formations. So we went down and he collected stuff. He actually took the stuff to a laboratory where he was at that time, because he was in a geochemistry program at, I think it was at University of Georgia in Athens. I'm pretty sure that's what it was, but I'm not 100% sure. It's been a while. It might have been at Georgia Tech. It was one of those two. Anyways, he had access to the geochemical library. So he went to his professor and they analyzed, and it was a slaggy glass. And they did argon dating on the slaggy glass. And the point of his, off the top of my head, I don't remember what half-life of argon is, but it's long enough that you don't see any traces of it until at least after 10,000 years of decay. So anyways, the idea was, is this slaggy glass going to be a natural feature, or is it going to be like an industrial byproduct? Now, if it's an industrial byproduct, it's only going to be at most a century old or so. So shouldn't be any argon gas at all entrained in the bubbles. A trace of argon gas would suggest that it was at least 10,000 years old. So he had it analyzed, and I should contact him because I haven't talked to them in 10 years or so, and get the details and specifics of the story again. But anyway, so he had it analyzed, and it showed up with traces of argon gas. So I don't know if he ever did any follow-up studies on that, but the circle has come around now again, I guess, with the Younger Dryas and the discovery of impact proxies in Carolina Bay rims by Firestone and his colleagues that I think would warrant coming back around and taking another look at the bays. But, some of the recent dating suggests that they're much older than late Pleistocene. But I have not looked into the specifics of the dating. I think it's probably optically stimulated luminescence dating, OSL dating, of sand grains into rim. And the first question I would ask is if I was, before I just accepted wholesale that those things are over 100,000 years old, is there anything that could bias the results of OSL dating? And there is, but you also have to look, and some of the earliest dates, of course, were carbon dating. And I think old Henry Savage talked about that in his book. But the interesting thing there was it seemed like the carbon dating was basically, you've got a basin, it's filled with organic material. And if you go out in the field, you go out in your backyard and you dig a hole and you just leave it, it's going to eventually fill up with stuff, presuming there's, winds blow stuff in, stuff gets washed in by the rain, leaves fall in. It's eventually going to fill up, right? Well, in that orderly sequence there, you would expect that the younger stuff is up top and the older stuff is down bottom, right? Okay, so in a lot of the radiocarbon dates, what was happening is that the oldest dates were towards the bottom, and they're dating to like terminal ice age. So there might be a conflict there, but
the youngest dates were at the bottom, or the oldest ones?
The oldest ones at the bottom.
Okay, yeah,
because that would have been the first stuff in,
right?
And then over thousands of years, they're going to fill up with peat, and that's my point. So
let me bring the circle back to Jeremy. How about that?
Yeah.
So the connection with the bays is that Jeremy was in those first excursions out. In fact, the first excursions into the field that I did with a scientific objective in mind, Jeremy was a part of those.
When you did that overflight, right? So here's one of the pieces of work that he's given me over the years. I don't know if you're going to be able to tell. Yeah, not really, but it lights up.
Yeah,
that's really cool.
So there's some.
Very nice.
It says solstice on the back, so there was some larger purpose to the lines that are on here. But yeah, that's not showing up well. But yeah, it's cool. So he did all kinds of unique things, make bookends and sconces, all kinds of light fixtures. He was one of Randall's students, but he practiced a lot on his own. He used the compasses, and I guess helped along the way with the compasses you make now, Randall, are going to be selling through the new website. He helped with some of the initial design of those, I think, and he actually taught some sacred geometry classes that I went to.
He made the very first version of these compasses, and all he did was he used wing nuts and 2 pieces of screen mold that he put together, and they actually worked pretty effectively. And then, me and Rowan, over the years of teaching geometry, we kept making little improvements, and yeah, so now we're going to have the new compasses that are actually quite nice and very, very effective. Because in the early days when I was teaching geometry, I wanted people to be able to draw. And, you can buy nice equipment that architects and engineers use, but for my purposes, that wasn't really suitable because I wanted to be able to knock these drawings out quick, be able to change, for example, if you're laying out something, just your initial light construction lines, you're just going to use a pencil. And then you want to pop the pencil out and you want to pop in, say, a colored pen or something to make the permanent drawing. Or you might want to use different colors or whatever. So you want to be switching back and forth. And so I wanted something where you could do that. So that's what we came up with. And we're going to have those for sale on the new website for sure. But I have this picture of that episode where Bradley and Jeremy and I went out looking for remnants of some of the mammoths that used to roam here in Georgia and North Carolina in the southeast. So Jeremy had some kind of, I guess he probably used some of his Sasquatch contacts, but they kind of filled him in on where we should look. And we found quite a specimen. I'll share the screen here. Where'd he go?
Man, I want Sasquatch contacts.
Helps you to see Sasquatch.
All right. I think this is it now. All right. Are we there?
Full screen that baby. Classic.
It is.
Okay. Let's see if people watching can guess which one is Jeremy and which one is Brad.
It kind of looks like a transition. Most hair,
It does.
less hair to Brad.
Wait a minute. Are you saying that if you were
New
to
shirt.
mix
New shirts.
Brad with
If you
Jeremy,
mix Brad
you
and
would end up with
Jeremy,
Randall?
You get Randall.
That's
And
scary.
Randall is the halfway point between Jeremy and Brad.
That's right.
Right. Well, that's the whole point. See, 3 troglodytes. What we have is, Cro-Magnon on the right, we have Neanderthal in the middle, and we have Homo erectus on the left.
I thought I was the advanced alien.
Oh,
We're,
that's it.
we're missing
Okay,
one.
so
in the
I'm
sequence.
Cro-Magnon. Neanderthal is to my left,
There we go.
left on the picture, and on my right we've got
Where are you guys in that picture?
we are somewhere right up on the Appalachian Trail, I believe.
Yes,
Oh,
it's not
okay.
far off the Appalachian Trail. Max Patch Mountain is in western North Carolina. Some nice overviews. Yeah, look into Tennessee and down into Georgia from some of those places along the ridge line where the trail goes.
And just for your information, Mike, that's not a real mammoth femur. Well, it's a real mammoth femur.
Not actually there.
It's not actually there in the
Thank
field
you.
with us,
Thank you for clarifying.
in case you were wondering.
It's Randall's Photoshop skills right there.
that is might be a little large, but yeah, that would have been a hell of a big. That's probably the femur of a Mammothus imperator, and even it might be a little big for that. But a Mammothus imperator, woolly mammoths weren't that big, 8 to 10 feet at the shoulder, about the size of a modern elephant. Columbian mammoths typically 12 to 14, and Mammoth imperator 16 feet high at the shoulder. Now those were some
Wow.
big,
Yeah.
yeah.
Yeah, I was going to say that guy for that femur, that size might be 14, 16 feet high.
Yeah,
And
he
they
would
were all
have to-
killed off by roving bands of Clovis people.
That's right.
in their wearing their Birkenstocks. Don't forget that.
Jeremy's not wearing any Birkenstocks.
Yeah, Jeremy.
Yeah, you'll note that he is has no shoes
Constantly
on his feet.
Yeah, he's barefoot in every picture.
Uh-huh.
That was the norm for years and years.
Yeah. Well, he had to regularly shave his feet. Because if he didn't, they were pretty they looked like hobbit feet.
Oh, okay. So he's part Sasquatch. That's what you're saying.
Well, yeah, we figured, this is, of course, really before genetic studies were readily available, but we figured it was probably at least 4 or 5 generations back.
Right.
There was definitely Sasquatch.
That's how
And
he's
this-
able to keep in touch. The
There you go.
genetics is
He went to
Speaking
live with his
of-
family. That's what you guys are saying. It's really fascinating that he just decided I'm gonna up and move up to the northwest, to the Pacific Northwest, and look for Sasquatch. That's really fascinating.
Yeah, and he lived out in the woods in North Carolina for a while, and it's actually in an area that
That has a lot of sightings.
that has a lot of
Right.
sightings.
Wow.
Yeah.
So yeah, he spent a summer, I guess, out there, or maybe longer in the Northwest. I don't know,
Did he have any-
10 years ago, and then I guess it's 2 or 3 years ago now. He left North Carolina and pretty much departed from all his possessions and went cross country back to the woods, as far as we know.
Did he have any success? I mean, did he tell you guys, that he had encountered strange things or heard stuff? Like, I know people go looking for Sasquatch and they hear tree knocking or they find stacked stones, or none of that. Didn't hear any stories.
Well, I think, didn't he say he could smell them once in a while?
Yeah, the smell
Because
is another.
they're quite pungent, I understand.
Yes, that's right.
It was kind of a personal quest. He didn't really share much with me about it, really,
Oh, okay.
of what he had found.
Well,
Yeah.
he and I used to have knockdown and drag out arguments about it, because I was taking the position that if there was a reality to it, it was something along the lines of Gigantopithecus, that it was,
Yep.
with very highly intelligent but very elusive, and he was leaning towards the more metaphysical interpretation.
Okay.
I mean,
What would that be?
well, that they kind of, I don't know, that they were like
Like interdimensional.
They're-
interdimensional beings.
Yeah, that they may be more like it may be more akin to ghost sightings than it would be to actual animals.
Okay.
Not necessarily that they're
different
ghosts.
time. They're in a different time, but still here on Earth, but a different time. So there's kind of a
Yeah.
dimensional window.
Yeah, they're-
They've
Time
got-
loops.
Yeah, it could be a time slip thing, or it could be another dimension thing. I mean, there are weird, things with Sasquatch like vanishing right before people's eyes in some of the reports. So they do act more like a forest spirit, if you want to go Native American style legend, than they do an actual physical animal. So
Okay, I'm gonna.
Great normal guy question, though.
yes,
Thank you, Mike.
fantastic normal guy question.
I try.
Yeah. Well, yeah, I got one more here to share.
Exceeding the bounds of normality. We've got Mike.
Yeah, I'm a little concerned though about Mike, because I'm afraid that he's actually shifted a bit from the normal side of the spectrum a little bit. He's drifting
Yeah.
over towards the abnormal side.
He's
So
broadening.
just be careful, Mike.
We'll move the goalposts.
Yeah,
if he goes too far.
We can move the goalposts. That way he can stay normal, relatively speaking.
Okay, okay.
I keep telling you guys, I'm only normal in relationship to you.
That's right.
Well, there's a
Where
new
do you
there's
get
a new
the-
normal everywhere else, right? So Mike
That's
might as well
right.
have a new normal too.
And the weirder you get, the more normal I stay. Just
Well,
keep
see-
tracking.
Well, see, yeah, I mean, your whole point of being here, Mike, is so we can have some kind of reference back to the consensus world.
That's right.
So we can have like at least 1 foot or toehold in the so-called real world.
I'm
Part
happy
of
to
it,
serve
not
the
all of it.
purpose.
Sorry, Mike.
Yeah.
So I'm going to do another screen share here. This is an interesting photograph.
Yes. You showed us this one. That's a good one.
did we look at this last week?
Yeah, but in the context of the Boulder fields, not.
Right.
Oh, okay. So
So-
now we'll throw in Jeremy.
Yeah.
Yeah. Yeah, he's out there, leaping over the rocks. What we need is videos of Jeremy, because he was very great, tall, kind of graceful. And he was a good runner. And he had a long stride. But yeah, he's, we're
Extremely
checking out
graceful.
the Hickory Run boulder field, composed of redstone, sandstones, and conglomerates. Very interesting. And then this one is the Blue Rocks boulder field in Pennsylvania. And so there we see Jeremy again. So these were two completely different trips here, or was it? With two completely different days, two completely different sites. And, boulder fields are always interesting because their origins are not fully explained. At least
Right.
the efforts to explain the origins of boulder fields using strictly gradualist or uniformitarian explanations never quite held up.
It doesn't really work.
And it's interesting because there's a stream that flows through here, but you don't see it because you can hear it.
It's under all the rocks.
Yeah, I would say those rocks are probably, it's a layer maybe 20 feet thick.
Wow.
But yeah,
Man.
it's quite large. And as we talked about last time, it's the trees are slowly encroaching upon it.
Right.
And as the trees encroach upon it, they will be shedding their leaves. And then over many generations, those leaves will fill in all of the voids and spaces. And eventually the whole boulder field will be buried. More trees will grow there. You'll walk through the forest and not even know that this thing is under your feet. But see, when you walk into the forest from here, you begin to see exactly the process, because you can actually, it's almost time transgressive. You can see from bare rock, like you see here, and then as you go into the trees, the further away you get, the more progressively they get buried.
Yeah,
That makes
there's a
sense?
little transition zone. Yeah. Where
Yeah,
it's-
transition zone, exactly.
where the encroaching is happening.
Yep.
That's really cool. I'd like to see that.
Yeah, and we're going to get
Somewhere
into
deep
this.
in the archives. There's some video.
Yeah, check this out. This is the Hickory Run.
Wow.
Now, yeah, and what's interesting to see here is because it's such a
Those are
flat
more rounded.
surface.
Yeah. Those are much more rounded than those other ones.
Yes, which is an indication of transport distance.
And all this is all the same type of rock.
No, this is the Hickory Run is a sandstone. Let's see. Redstone.
But each of these beds is essentially the same type of rock.
No, this is one type of rock.
Well, that's what I'm saying. They're two different fields with two different types of rock.
Two different types of rock.
But within each field, it's homogeneous.
Yes, that's right. Yeah. So these are two examples of what are called boulder fields and or boulder streams. Whether it's a boulder stream or a boulder field depends on width to length ratio of the feature.
What's the source of these?
Well, it's in the uplands. They were washed, I would think. I mean, I don't know how else you're going to transport them other than, if you have a
right,
very.
But I understand that. But where have they found the source for these?
Yeah. I mean, within not too many miles away, there are Appalachian mountains. So if you have a mass wasting event, it's the only thing that makes sense. I mean, like, when you read the studies on them, they're scratching their heads trying to figure out the exact mechanism. I mean, they know where it came from, but how do you get it from point A to point B and spread it out on a flat surface? Okay, so here in the Blue Ridge, let's see. This is the quartzite. So bare stream-like accumulations of boulders along valley bottoms occur at widely separated localities along the Blue Ridge from southern Pennsylvania to West Virginia. The boulders are loosely packed, unsorted, heterogeneous in size and shape, and range up to 12 feet in length. The sound of running water beneath the surface is audible. And in fact, in that picture right here of Jeremy, he's actually standing in that picture, listening to the running water. But that running water had nothing to do with the emplacement of this boulder field. Obviously.
We're looking for a snake.
Yeah. Okay, so here we go, Mike. Here's the answer to the question. The boulders are of quartzite derived from neighboring slopes and ridges. They are now lichen covered, are undergoing disintegration in place, and show no evidence of appreciable present-day movement. The rock streams appear to be fossil forms and are best explained as a product of solifluction under paraglacial conditions in Pleistocene time. Solifluction is a type of mass wasting or mass movement. Kyle will look that up, SOLI, solifluctions, and it'll give us a little more precise definition that I would give you at the time. So let's hear what that says. Paraglacial simply means near the glaciers. So the idea here is you've got an environment that's not covered in glaciers, but the glaciers aren't far away. That's paraglacial, right? So they're best explained as a product of solifluction under paraglacial conditions in Pleistocene time with subsequent removal of interstitial material by running water. This explanation applies also to the boulder-choked valleys and subdued, overgrown talus slopes, which are more widespread in the area. So that's just what I was talking about. There are lots of these things around, but because, as it says there, they're overgrown. So because they're overgrown, people aren't aware of them, that a lot of this stuff is underfoot. And that's a big part of, trying to teach people this stuff, is because a lot of the evidence is obscured now. But it's all around us. And in this case, you might be walking on a trail in the forest and not understand the nature of the landscape under your feet. And what'd you find for solifluction there, Kyle?
It says the gradual movement of wet soil or other material down a slope, especially where frozen subsoil acts as a barrier to the percolation of water.
There we go. So frozen subsoil allows this saturation. But then if it melts, say it gets warm enough, then it becomes fluidized. So you got a picture. It's really almost like a slow mud flow, right? Although in this case, I would argue that it's not really actual solifluction the way you described it, because I would say the emplacement was much more rapid.
Right.
And one of the things that might have been going on is that during the deglaciation, you not only have the rapid saturation of the soil, right? You've got to somehow see, here's part of the problem. It's one thing to have saturate the soil, but how do you get it loaded with these millions of boulders?
Yeah, it says it's a relatively rapid process in paraglacial regions and can result in the active development of slopes.
Yeah, and you know what? That interpretation of it there probably stems directly from the study of boulder fields, like we're looking at here. But so see, then this explanation applies also to the boulder-choked valleys and subdued overgrown talus slopes, which are more widespread in the area. And then the previous sentence, subsequent removal of interstitial material. So picture you've got a mud flow, a very fluidized mud flow choked with all of these boulders, right? Spreading out onto the valley floor from the adjacent uplands and ridges and slopes, spreads out. Okay, so now it's emplaced. Once that event is over, it now, because this event was on a scale beyond what would normally be effective erosion or deposition in that particular area. So because of the scale and magnitude of it, once it's over, it's pretty much left in place. So now the running water, what it does, it doesn't really move the boulders, but it begins to wash out the material, the mud that these boulders would have been encased within. Does that make sense? And particularly if you have storms, so you have a lot of extra runoff, it's going to wash the mud out. But you're looking here basically at two very distinct regimes of deposition and erosion. The erosion that would wash away, the fine-grained soil from between the rocks is a whole different order of magnitude than the depositional event that put those rocks there in the first place. Does that make sense?
Yeah, it does.
Yeah.
Have you seen, I don't want to get too far off the main topic here, but have you seen Black Mountain in Australia? That's actually a pile of boulders, a mountain-sized pile of gigantic boulders. And I've always wondered what geological process could have formed. Maybe we can look at that sometime.
Sure.
Yeah, I thought of the same thing the last time we were looking at the boulder fields.
It's literally a mountain made of boulders, of gigantic black rocks.
So you got to, first of all, in a case like this, try to begin to, if you're going to try to explain the whole process, you got to explain, okay, how do you get so many pieces of broken rock?
Right. Yep.
What's the story there? You get all of these pieces of broken rock, millions. And then he goes on.
That's the first question I would ask. What broke the rock up? Where does the broken rock come from?
Well, this particular geologist, in the conclusion of his paper, says that the tumultuous appearance, and if you look at it, it's not moving, but it still has what he's describing as a tumultuous appearance of the surface, suggests, and this is a key phrase right here, arrested motion after forcible movement, somewhat in the fashion of an ice jam in a river. So you've got this process. It's a forcible movement in placing, somehow extracting these boulders from the ridge tops and the slopes, transporting, conveying them down onto the valley floor, and then spreading them out on the flat valley floor, so that the whole valley floor is basically mantled with these rocks that came down. So it seems, you need saturation. But is the saturation going to be enough to supercharge this matrix of muddy material with all of these broken rocks? So I think with Mike, the question is how do you break up all these thousands upon thousands of rocks in the first place? And I would suggest that the saturation is being accompanied by perhaps seismic events in the region, most likely due to deglaciation, which is also related to why you're having this super saturated soil in the area.
And also, if you had, this sort of an idea of an ice dam, but just a crowded flow that's full of huge chunks of ice that are scraping against the walls of the canyon as they go. They're going to be breaking rocks. And then the rocks are going to go to the bottom of that flow, of course.
Yeah.
While the chunks of ice are staying up near the edges of the canyon.
And one of the things interesting about the Hickory Run is, like, you'll notice here that as you go from the top end of the flow to the bottom end, the rocks, this is the top end of the flow. Look at how sharp and jagged the rocks are here compared to when you get a couple of, 300-400 yards farther down. All right. So here's the upper end of the boulder field. And there's further down, maybe 300-400 yards farther down. And as you get to the lower end, you see that the rocks are rounder and smoother.
Yes.
And so I think right there, that's, direct indication of transport, and could also be used as a so-called paleo current indicator. Because in this case, the current was going to be flowing from, obviously, if you've got this depositional layer there and you have evidence that this layer was not transported as far as this layer, it would suggest that the flow is, from the sharp angular rocks towards the more rounded rocks.
Yeah.
Because they got transported farther. So with that kind of evidence, you can determine which way the flow was.
I would be interested to know also, I wonder if it's possible to figure this out, like how fast is the boundary of trees encroaching? And could you then, reverse engineer that and figure out how long it would take for this boulder field to be completely covered? And then maybe you could use that as an estimate for how old it is.
Well, yes. And in fact, if we go on here this is something I wanted to be covering soon anyway.
Okay.
But like here, this is Appalachian mountains and plateaus, vast areas covered by bouldery, generally unsorted and unstratified debris lie along mountain foot slopes in many parts of the Blue Ridge. The origin of these foot slope deposits has been considered problematic. Study of modern debris slides in this region, however, makes these deposits somewhat more understandable. But then when we look at the next slide here, now this is typical. Of course, they're much smaller, which would imply a less vigorous flow of smaller magnitude than what emplaced either the Blue Rocks or Ringing Rocks in the Hickory Run boulder fields. But this is very, very typical of the stream bottoms of all throughout the Appalachians, right? Now, if you go, here's where this is the Pigeon River flowing through. It's at the foot of Cold Mountain, the fairly famous Cold Mountain that the novel and the book was written around, the Civil War epic. Anatomy of a valley floor. Boulder cobble layer is superimposed on a scoured bedrock floor, and there's an immature soil horizon capping the boulder bed. And let's see, I should have, right here, let's see. Scoured bedrock, you can see there's several exposures of scoured bedrock here. There we go. So that's actually bedrock right there. So it gives you an idea of the thickness of this boulder cobble layer. It's about 4 or 5 feet thick, and it's splayed out over a bedrock floor, right? If we look at the next one here, you can see for scale, actually, there's Jeremy again.
There's Jeremy.
We're out there collecting rocks for his rock shaping craft. That's what we're actually doing there. But I'm also, checking out the geology. So we have right here an exposed bedrock of a metamorphosed gneiss, right? So you got to picture this. This whole entire valley floor is mantled with this 5, 6, 7, 8 foot layer of cobbles and gravel and boulders.
And it's a scoured bedrock, which means something washed whatever was there away and replaced it with this cobble.
Mike got it, nailed it. Right. That's exactly right, Mike. Okay. So right there, Mike, you've justified your existence for at least another 2 or 3 episodes. Excellent insight, Mike. Yes, that was what I was going to see. I was going to see if Kyle actually was putting that together. But you beat.
I was just thinking of the word nice.
Nice.
So right there, you see that arrow that's pointing, that's a metamorphosed gneiss, and that is the bedrock, right? So you've got this layer, just like Mike said, you had to have a scoured surface first that exposed the bedrock. And then you had to have the deposition of the cobble, boulder, gravel layer. And then you have topsoil forming on that. Now let's see if we have here. If you look, you'll see over here on the left, you'll see this layer of topsoil. It's about a foot thick. Well, I did some research in this environment of Western North Carolina under normal gradualistic circumstances. You can assume about a 1-inch thick layer of topsoil every 1,000 years. So
let me guess. It's 12 inches thick.
it's about a foot. Yeah, maybe 16
There
inches
you go.
in place. Yeah.
Mike's nailing it. On fire tonight, Mike.
He is, the man is on fire. He is. I mean, look, I've seen this before in Mike. So check out over here on the right. You'll see that you've got this, the topsoil is very distinct from the underlying cobbles. And if we went over to the tree line and started digging down, we would find the same valley floor. And in fact, I would say that there was a time, if we had a time machine and we could go back 12 or 13,000 years to the right day, the right month or so, time of year, whatever, the right year, what we would see is a vast valley floor just basically covered in this stuff right here. And what the whole floor would look like is what you kind of are seeing right here. You get it? So
yeah.
How do you get that as the end result without having some kind of a extreme erosional event followed by an extreme depositional event? And then once those are over, not much happens because now it's a fossil feature. So in other words, the whole valley floor here is a fossil.
Yeah.
And you say this is predominant pretty much in Western North Carolina up along the Appalachians?
Oh, yeah. Oh, yeah. Absolutely it is.
I mean, we have this here too.
Yeah.
Kyle and I've noticed we've walked many stream beds, and there's a little bitty creek, but there's this enormous cobble / boulder field all around it.
Yep.
And then you can see farther up, you start to get thin topsoil.
Right.
And it's become clear to us looking at that stuff now. And you can also find places like that where you're pointing out where the exposed bedrock is, and it's clearly it's limestone in our case, and it's clearly been scoured by water.
Right.
Right. So yeah, it's become clear to us that a lot of water moved through these areas.
Yes.
Very quickly, carrying a whole bunch of crap that they later dropped.
You got to what you actually have to understand is what you're seeing here is the aftermath of highly erosive floods, flushing these valleys out, scouring right down to the bare bedrock. So whatever was there before is now gone.
Yeah.
Then as the floods decline, the same flowing water that scoured the valley floor now drops its cargo of huge amounts of broken rock that's being rolled and transported in this flood, mantles the valley floor with it. It's over, and now it sits there for 10, 12, 13,000, 14,000 years, whatever the length of time.
Right.
And the normal processes come in and slowly begin to conceal it. See, that's the thing, is that the modern processes are slowly destroying these fossil features, but so slowly that, after 10 or 12 or 15,000 years, they're still here. Now, how many people do you think will drive through this valley, see this, and never even have the slightest thought of what the story that's being told here by what you see?
Right.
Probably just about nobody. Interestingly, the time...
Everyone who watches this show. Everyone who watches this show.
Well, everyone who watches this show, yes.
That's what I'm saying. That's what this show is for, is to teach people how to be able to drive through valleys like this and see the thousands of years of geological story in these features.
Creating a context so they can recognize it, right?
Right. So, again, this would be going back to our little metaphor of fingerprints and footprints. This is kind of a footprint, although it's not an obvious one. It's not like a meteor crater or an extinct cataract, but of course, a lot of people might look at an extinct cataract and not know it's an extinct cataract. See, we have extinct cataracts all over the southern Appalachians, but they're generally so overgrown, and most people it's just a big amphitheater with a little waterfall going over it, and the amphitheater is 100 times bigger than the modern waterfall. Who stops to think about the fact that the amphitheater was originally created by a flow that might have been 100 or 1,000 times greater than the modern floods that are running through that particular valley?
Yeah.
10,000.
But that's what we're looking at here. So then this was another study. Now I was studying all this. This goes back to the 80s. So me and Jeremy are out there studying this stuff in the 80s and going out and I met Jeremy in 89, I think. So this is 89, 90, 91, 92 right there. But a lot of the studies that I had already been looking into, I'd already done some of the studies. So that's how I knew, okay, we're going to go up here to Cold Mountain, and I know that there's bedrock gneiss up there, and we're going to go up there and check this out. So one of the studies I read was this David Scott Schaefer. This was from his unpublished master's thesis at the University of Tennessee, published in 1984, Late Quaternary, Paleoecologic, Geomorphic, and Paleoclimatic History of Flat Laurel Gap, Blue Ridge Mountains, North Carolina. And he says that the widespread existence of relict, meaning that it's a relic of the past, relict talus, block streams, and block fields, and colluvial fans that date from the late Pleistocene and early Holocene. So we're talking right there in that transition, right there. That's pinpointing us right back to the Younger Dryas era, right? Is evidence of a former severe paraglacial environment characterized by intense freeze-thaw processes in and around Flat Laurel Gap during the full and late glacial. So one of the things about the paraglacial processes is when we're talking about the creation of these boulders originally from what would have been a solid continuous mass of bedrock, that's where we can get into the idea of Mike freeze-thaw. So when you have intense paraglacial, what you're doing is you've got very intense cold, and then that's followed by a seasonal warming, and then intense cold. So you've got this freeze-thaw cycle. That can actually go to work on the bedrock. I still would think, though, that a seismic event is going to be necessary for a full explanation of, I don't think, you see, because of the fact that when we look at the Hickory Run Boulder Field, for example, it's all transported. Paraglacial phenomena, while it can fracture rock, it tends to leave it in the same place, right? So it's still interesting to try to resolve it, and it hasn't been resolved yet.
This has kind of been an awesome detour, thanks to Jeremy, into what we're going to be getting to with the Megafloods.
Yeah.
I see your program here is Cataclysmos, but
I don't think it's a detour. I think it was a perfect entry.
Yeah, let me just kind of connect the two.
Sure.
Because what we're seeing here is just one little regional expression of this evidence that there was something that happened that was another order of magnitude. And the last date that I had up there was putting it right back there in that window. They were using, we'll be coming back to this stuff, but it was talking about thermoluminescence dating, putting it right back to the terminal ice age period. And so what we've been looking at all of these episodes is evidence of fingerprints of some kind of a cosmic event, right? So I want to get to where we kind of have an understanding of both of these things, that yes, there was an event that left this impression in the ice, in the lake deposits, in peat bogs, etc. But then this event had outward manifestations in all of these varied forms. What we just looked at was one of those forms. We just saw evidence that there was something that happened. So the question is, and as Mike saw instantly, we're talking about flushing the valley. We're talking about washing in huge amounts of rock and boulders, depositing it, and then leaving it sit there for 10 or 12 or 15,000 years, whatever, forming the soil over it. So now people go, they build roads, they build their houses on it, trees are growing. Nobody suspects that if you went back in a time machine not that long ago, it would look completely different, right? So what we're trying to do is go, something very unique happened here, right? It left its signature in the landscape in this form that we just looked at. Now, it does appear that at the same time, something else happened. Around large sections of the world, we have deposition of microspherules that only form under high temperature. And we have nanodiamonds, and we have iridium and platinum showing up. We have fullerenes. We have melt glass that's showing up. So the question is how do we connect all of this together? And is there a connection? Would a flood of such outsized scale and magnitude as must have done its handiwork, its geomorphic handiwork in this valley that we were just looking here, the valley of the Pigeon River, was that event connected somehow to the deposition of nanodiamonds and microspherules and melt glass? That's kind of where I want people to be thinking about this. So, yeah, let's take a little quick break.
We'll take a quick break and be right back.
All right, ladies and gentlemen, welcome back to Kosmographia. And before we get back into the Jeremy mystery and other geological features, we wanted to talk again about the CBD oil that you've been trying out, Randall.
Yes. I'm actually quite enthusiastic. I've tried 3 different, this is my 3rd type of CBD oil that I've tried. And I'm just learning about the whole endocannabinoid system and how that works. It is pretty phenomenal. But I like what these guys are doing. I'm still learning about their product, but I've had really good results in terms of my sleeping patterns. I think that that's the first thing that's really I've noticed is when I forget to take it before I go to sleep, it seems I don't have the same depth of sleep. And this is what Mike Robertson told me that I should expect. And I think that that's definitely the case. And I've noticed when I have a better night's sleep, I feel better all the next day. So, and then Julie is using it. She's had, she worked as an electrician for years and years, and she began, used her hands a lot. Well, she started getting arthritis in her wrists and her hands and so forth. And she's actually gone and tried these various infusions that cost like $3,000 a pop. I'm not sure what the drug they shoot in, and it's helped her somewhat. She's been using the salve made by this company for 3 days now. And today, and this is not an exaggeration, today I say, Julie, she's carrying this heavy shelf and setting up a heavy shelf in the other room in there for some of our overflow books. And I said, you need to get help with that. And she's handling this shelf, right? And I said, Julie, you realize that shelf that you're handling, it's built out of 3/4 inch plywood, right? It's pretty heavy duty shelf. And she goes, oh yeah. She says, those my hands. So I don't know if it's 3 or 4 days she's been doing the salve. And apparently she thinks it's helping. So we'll see.
Sounds like it.
But I mean, it really does
CBD
seem like
from the
helping.
gods.
So what Mike Robertson says is, what's most effective is if you do both the internal and the external. So I'm day 2 trying it on my lower back, which, from 30 years of doing construction work, my lower back has taken a beating. And so I'm testing it. I'm experimenting with my lower back, and my right hip is the one that tends to maybe have some traces of arthritis in it. And then, of course, my knees have taken a lot of beating because I've spent a lot of time working on my knees. When you're framing in your house or whatever, or you're down on your knees, you're working. So by next week, I'm going to have spent a week with this salve on my knees. So we'll see. I'll give a report on that. But yeah, I mean, I've definitely come to believe in the efficacy of CBD oil and byproducts. It's just a matter of deciding which is the best source. And so far, I'm really liking this company. I really am. Let me make sure I say it here. It's the CBD from the gods. We looked at it last week, and I pointed out how I was particularly attracted to this since they were using my likeness on their logo. You recall that, right?
Yeah.
Yes.
This is the Apollo. This is the oil that I've been doing here. The Apollo full spectrum hemp extract. And if you want to learn more about it, you can go to cbdfromthegods.com. Check it out. And I will be giving you my report on a week of using the salve. It really smells good, actually.
Yeah, you're gonna have to give them a code so people that check in through Randall. Yeah, I think Russ mentioned that. That's the way to
Kyle
go.
did, yeah.
Yeah, because
Promo codes are good.
I'm really, one of those. I believe that there's a whole pharmacopoeia out there of things that we've even just begun to tap into yet. And the cannabis plant seems to be a miracle plant, from everything I can tell. I mean, and once I think we've had another decade or so of working with it, without it, the stigma of it being illegal and all that, who knows what possibilities are going to open up. But something's been working good for me, and I'm pretty much sure that it's been the CBD oil that I've been doing. And this one, I really like this. And this one has a bit of I think they actually put a little bit of a chocolate flavor to it. It actually tastes good. The first one I used, I couldn't, whether it was effective or not, I don't know, but the taste of it, I couldn't deal with the aftertaste. So anyways, yeah, ask me how it's going next week.
All right, we'll do. We'll get the weekly report.
We want a healthy Randall for long term, no doubt.
Yeah, absolutely. And the thing I was going to suggest, Bradley, was we get you some of the salve and we start massaging it into your yes. Now, if you started regrowing hair, that would certainly convince all the skeptics that CBD is a miracle product.
Miracle product. I need to get some for my back. I need to get some for my back for sure. I can't wait.
Let's give it a try, man. I want to.
Yeah.
Because I might have good results, but the question is, everybody's different. So I seem to be responding to this though really well, particularly in the sleep patterns. And Brad and I, having spent so much time on the road, he knows that, man, sometimes I wake up and, we got to get an early start and I wake up at 3 a.m. and I can't go back to sleep. God, that sucks.
You end up sleeping while we're driving around and you miss a lot of the territory we're going through because you didn't sleep the night before. Yeah, you're sleeping in the truck just little at a time. So, yeah, that'd be great. If
so lame.
Sleep.
That's really lame, Randall.
Yeah, man, I can't believe that. Take more CBD oil.
May have figured something out here. It's a good thing.
Well, I'm taking that along with several other things. And so I think, there's a combination of everybody's got to kind of work out their own formula, what works best for them. But obviously in these times, I think doing a good, healthy dose of vitamin D is important. 5 to 10,000 international units a day is probably a good dose. So I've just upped from 5 to 10,000 IUs a day.
Wow.
So we'll see what that does. But yeah, there's several other things too. Natural anti-inflammatories, because I think inflammation is a big part of a lot of the things that.
Yep.
Yeah. Mm-hmm. And CBD oil or CBD products seem to be able to go directly to dealing with the inflammation issue.
Mm.
All right. So we were talking, Mike thinks we should finish up the Jeremy story.
Yeah, Brad had an interesting part of the story that I wanted him to tell.
Yeah, this is really the final chapter of Jeremy in our lives.
Well, he just he had some prime property in Atlanta, and he was a regular feature in an area called Little Five Points down there, and had two big Afghans. So he'd walk through the parks, and they built the Jimmy Carter Center down there and Freedom Parkway when the Olympics came through in '96. So he's already a legendary fixture in that part of Atlanta because he'd be seen walking multiple times through Freedom Parkway and Little Five Points area with these two big Afghans, and him, long hair and graceful like we've already seen. So he was a sight. So people really noticed him. But at one point they kept expanding, and he moved up here to North Carolina. Worked with a guy that had studied some Sasquatch research up here, had written a book or two. I don't recall his name, but
well, throw in that when he sold his prime piece of property, he probably came out in Fat City.
I'm guessing that. I never heard directly, but yeah, I mean, since it was really amazing.
I don't think he owed much on it.
Site, and he'd been there for decades, I think.
Yeah.
Because I used to go over to the Carter Center in the evenings and look at the skyline. You're basically looking down Freedom Parkway, which goes into International Boulevard and Martin Luther King Drive down there, and you can see the whole skyline of the city. And he was just below that, so he could see the whole downtown area from where his property was. So anyway, a couple of years he called me up and he says, "Well, I'm coming through. I'm headed out west, and I got a bunch of stuff. Thinking I could drop it off with you, and I'm going to go back out to the Northwest." So he had tubs full of stuff in his van, and he left me his life collection of books and sacred geometry notes and things that he had gathered and accumulated. And I've got shelves full of stuff from Jeremy that he just he was heading cross country and had to lighten a load in a van. And I'm a caretaker of them now. So I hope he's going to come back cross country and touch base with us. And
so
tell me what's the most important thing to go through that he left with me, because it was quite a stock of stuff, and many years of it's from studying with Randall.
So what year was that he found?
I think it was 3 years ago. I've been up here 4 years plus now, so
okay.
I think I've been up here a year.
Okay, so I've gotten 2 mysterious postcards from him with no return address that have shown up, and not much said on them. Just I think one of them was a link to something. What was it? Gosh darn it, I don't. Yeah, but yeah, there was nothing I could like write back to him or
right.
Yeah, here's my email address. Send me an email, whatever. Yeah. Hey, I'm doing a podcast now out in the woods. I've got some of the locals here. Brings in these 8-foot hairy guys.
So he went to Washington or Oregon? Was it Oregon? You guys said you don't really know.
I don't know for sure, but that was where I thought he went. Yeah, that's where he went about 10 years ago. So I'm not sure what he found there that he was able to go back to. And I know a couple of people out there, and I told him, I could connect him with a few people, but he was following his own drummer out there.
Yeah. So somewhere out in the Pacific Northwest is a barefoot millionaire looking for Sasquatch. that's the gist
like
of
Jesus.
The story.
It talks like
Jesus.
Jesus.
It looks like Jesus. Wow.
Well, if you see, So like I said, I think by this time, you might need to be looking for a family.
Yeah.
Oh man.
Yeah. So this is Jeremy and my son quite a while ago in a creek up in the Smokies. Let me get the better.
Wow, that is beautiful.
Yeah.
Yeah, look at this. Now, the thing to realize there is that those boulders were not put there by the modern stream.
Yeah.
Now, the exceptional 100-year floods that you might have through this creek valley here, which is Big Creek, North Carolina, may, adjust the boulders, maybe jostle them a bit, but basically they've been there since the day they got dumped. Now the question is what was the process that put these boulders here? That's where it gets interesting.
I thought you were going to say the thing to notice is that he actually has boots on here.
That's what I was gonna say. The first thing I noticed is he's wearing shoes.
Yeah, wait a second. I don't remember that anytime.
Huh.
Are you sure that's Jeremy?
Well, notice he's got shoes and his hair is somewhat trimmed back.
Yep.
Yeah.
Yep.
Maybe it.
So this
I
may have
thought-
been one of his last ditch efforts to sort of regain a sense of normalcy. But I think maybe after this, he pretty much just gave up on it
Yeah, short term.
and went back to being the modern day incarnation of Enkidu.
How many people are gonna get that joke? That's the question.
Look, if they get that
We
joke,
got it.
they get an attaboy or an attagirl, depending as the case may be. And I do want to mention, Mike, you get an attaboy.
Yes.
For putting that.
Thanks.
He gets an attaboy. So somewhere who's ever keeping track of attaboys, get one down for Mike.
It's going in the book.
Going in the
Going
book.
in the book.
All
Yep.
right.
One
Tally
attaboy
one-
for Mike.
tally one for Mike.
Yeah. So yeah.
Oh man, look at that.
Now that guy slid down the mountainside.
These are erratics or just
Not glacial, no, because there may have been limited glaciation in the Appalachians of North Carolina, montane glaciers, but there was no ice sheet here. You had to
Right.
go all the way up to Pennsylvania to get the lower margin of the Great Laurentide ice sheet.
Ohio River.
Yeah. So this is very typical of stream valleys. You see all over the southern Appalachians.
Yeah.
So what are you looking at there? Well, you're looking at this big pile of boulders and rocks of all sizes, and some sharp and angular and some more rounded. And for example, this is Boone Fork Creek that's on the flanks of Grandfather Mountain, and you can follow this stuff up for miles up these mountains. Look at this. And the way the rocks are stacked is very interesting and important, because this tells you a lot about the nature of the depositional events that were involved here. Like what we see here is called imbrication. Have we talked about that?
I don't think so.
No.
Okay, well, let's talk about imbrication. Okay, so behind me on the bookshelf here, let's see.
Yeah. There
See
it
these
is.
books and how they're tilted like this?
Talk
Yeah.
toward the mic, Randall.
Okay, you see these books, how they're tilted like this?
Yep.
Push them this way. If I put the books over here and I push them this way, that's imbrication right there.
Oh, okay.
Get it? Except in geology, it's rocks, boulders, and it's a paleo current indicator. All right.
All right. Okay.
So some places it will be very obvious.
They're tilted and stacked on each other in a direction of the flow. Is the idea? Is that
There you
That's
go.
exactly
There you
the
go.
idea.
Okay.
That's exactly the idea. And let me show you.
That's probably what it says if you look it up, Russ.
Let's see if I can find some great examples of imbrication here. Let's see.
Oh,
Okay.
man.
Here we go. Here's a good one.
We're going to eventually get to this program.
yeah? Okay.
All right. So when you're looking at this now, which way was the current flow? Right to left or left to right?
It looks left to
Left
right.
to right.
You got that. That's it. Yep. Came from the left, moving towards the young man standing there.
Right.
So that's imbrication. And you see many examples of that. And sometimes you might see imbricate like this. It might be, in the riverbank where the water has exposed the internal structure of the material, and the rocks will be encased in a matrix of finer material, clay or mud or whatever, but you can still see the imbrication in them. Other times now, this had to have been a pretty substantial flood that did this, and I think this was taken shortly after Hurricane Ivan caused major flooding all over the southeast, and so
Well, yeah, that one in the back is huge. I mean, it probably isn't this wasn't moved there by the same thing that moved those ones in the front, right?
Well, maybe not. Maybe not. I don't remember that specific one.
Yeah.
But since we're looking at this, I'm going to pull up another.
It was 2004.
Probably 2004. Yeah. Let's see. Okay, I've got some great.
There were 2 years in a row. Opal was 05, and Ivan, yeah, 2 bad ones in a row. 2 years in a row.
All right. You see this? You're now learned in hydrology, paleohydrology, imbricate structure. Okay, so which way was the flow here?
There we go.
You see the imbrication now?
Yeah, that one looks right to left.
Right to left. That's exactly it.
Okay.
Right. So you see what I'm saying about a paleo current indicator?
Yes, that's wow.
Yeah, yeah. And so that's imbrication right there. And this is what water does when it moves and sorts rocks. Now, this was the stream flood. It was a pretty substantial stream flood. I forgot which one it was, but yeah. So I go up there to explore the creek valleys after major rainfalls, because then you can see stuff, because obviously this stacked up along the creek bank is not going to be there a week or 2 or 3 weeks later, much less a year or two, at least not rocks this size. And, I've got the little, the little radio receiver there next to it for scale. So you can kind of see. Let's see if I can go to the next slide here. Yep, it's current flow. This is blurry, but it's still, I think you can still make it out.
Yep, that one's left to right.
Left to right. Yeah, that you got it. Current flow this way.
That's really cool.
All right, how about this? Now this is all, water flow that stacked these rocks this way.
That one also looks left to right.
Yeah. Yep. And now we've seen this one.
Yeah.
Now you can tell that the water flow here, which is probably a 10 to 50 year flood, this would have been quite a bit bigger.
Right.
And then check this out. See the imbrication here?
Oh, yeah.
Yep. And then how about this?
Wow.
Oh my
God.
You see the imbrication?
Yep.
Yes.
Now, I can assure you that the modern creek did not emplace these boulders. So the question is what did?
Yeah.
And when did it happen? And when it happened, I mean, in the aftermath of it happening, these boulders have pretty much, they're pretty much where they were put whenever this thing was through happening.
Right. Something as large or larger would have to take place to move them again, right? That's
Well, yeah.
Yeah.
I mean, those are huge boulders. Huge boulders. So, yep, this is scale invariants we're seeing here. This is beautiful examples of scale invariants. And here we're looking at this. Look at this. This is just a local creek. It's a sand gravel bar along the South Fork of Peachtree Creek. Okay, after the passage of Hurricane Ivan flooding. Now, here we're looking downstream, but in all bars created by water flow, notice, I'm hoping you can see this, the material at the upstream end is coarser than the material at the downstream end. So whenever you have a gravel bar like this, you're going to have the coarsest, because obviously, and especially if you have a flood, which increases the velocity of the water flow, which increases the amount of material entrained in the water flow, then once the water flow begins to decline, it loses its capacity to entrain sediment, because the sediment load and the size of the sediment is going to be a function of two things: the depth, but even more than the depth, the velocity of the water. So when the floods decline, not only is the velocity, the depth decreasing, so is the velocity. And so when the velocity decreases, the competency to pick up and transport material begins to decline. Well, when that happens, obviously, the larger the sediment clasts, or the larger sediment is going to settle out first, isn't it? So when you're looking at a gravel bar, even if you're looking at a fossil gravel bar and there's no creek there anymore, you're going to generally be able to tell which way the water flow was, because there will be coarser material at the up current end and finer material at the downstream end. How's that? Does that make sense?
Yep.
So which end would I do gold panning on?
That's, I don't know. I can't answer that.
Well, it'd be the heaviest stuff, Mike.
That's right. The upstream end.
So yeah, this is,
it's an obstruction, and the velocity slows down, so it drops that load first, and then it builds up and carries the lighter stuff farther to the far end of the bar.
And most of those bars are also on the insides of curves and stuff like that, right?
yes.
Okay.
Because if you think about this, if a stream is meandering, think about all the water molecules are very social, and they want to like hang into each other. You know, this little guy molecule is running along next to a guy here, right? And there's another guy here and another guy here. Now, if the stream was perfectly straight, they could all go at the same speed and they'd stay right in line with each other, right? But just like a horse racing track or a foot racing track, you know, if you've got the inside of the curve, you're running a shorter distance, aren't you? So
Right.
what happens is there's a
down.
mean velocity in the water, and this is important to understand because this concept can apply to the understanding of a lot of landforms. Because now what you're going to have is that there will be the mean velocity of the stream as a whole, but generally on the outside bends, because those water molecules are having to move farther than the inside bends, right? The outside bends are moving faster to keep up with the mean, with the average. And the inside bends are slowing down because they're all trying to go the same speed, right? And that speed that they're going for is that the idealized speed would be the average stream, as the whole, right? You could imagine an idealized situation where, again, you've just got a straight channel, so everything's moving at the same rate. But as soon as you take the channel and start curving it, right, now what you've got is you've got differential velocities of the water moving. So when the water is moving faster, it becomes more erosive. And what you can see generally in any stream channel like this is this balance, right? Because what you're seeing there is on one side, it's eroding, but on the other side, it's depositing. So it's cut bank on one side, point bar on the other side. So it's building. It's building here, eroding here. And the material that it's building the point bar out of was taken from some cut bank upstream. Now, where I'm interested in all this, of course, you can study and you can see these. See, the thing about water flow is it's scale invariant. So when you look at like the sandbar, the formation of a sandbar on a creek, and then you go out to somewhere like the Channel Scabland, and you start looking at features out there that normally might escape you because they're on such a mega scale. But now you have a frame of reference of what you're looking at.
You started learning some of this early on when you were racing canoes.
Oh yeah. Yes, that's exactly right. Because I spent a lot of time in rivers, in canoes, and so yeah. One of the things you do when you're spending a lot of time in canoes is you have to like really get a feel and work with the current. And learning that, so if you're paddling down a river, you go to the outside bend, you're going to actually be going faster than the mean velocity, but you're going farther. And of course, the main trick was to keep the gunnel of the canoe perfectly parallel to the streamline. So wherever you were in the river, in stream, stream hydrology, you've got the concept of a streamline, which is that you imagine for mathematical purposes that it's composed of a whole lot of little streamlines, millions of these, all like it's all a bunch of threads together. See, now what you're trying to do when you're canoeing, and I'm not much of I haven't done a lot of kayaking, probably very similar, but certainly in canoes, you want to keep the gunnel of the canoe as parallel to the streamline as possible. And typically what will happen is if you get skewed to the streamline, and then, you turn perpendicular to the current, then you're going to swamp. And that's when most people swamp, is the canoe spins around and now suddenly they're perpendicular to the current. So the whole key of, like, if you've got canoe, whether it's a single or a tandem, you're trying to keep yourself parallel to the streamline. So one of my fantasy worlds is retreats where we actually get to do some canoeing. I think that would be just extremely fun. And we did do that on some trip. Let's see, it was up in British Columbia on Moraine Lake,
right,
where we had to go up to we were going up to check the upper end of the lake. So there was no way to get there but by canoe. And
can we not do it in a glacial meltwater lake so that if I fall in, it's not like 12 degrees? I need to get better at a canoe before we do that.
Well, lakes aren't bad because lakes, there's no current. So unless you're just a complete, dumbass, you shouldn't tip over in a lake. Okay, well.
You're talking to me here.
Oh, okay. Yeah, well, flat water is different than flowing water. Flowing water is more fun.
Yeah.
Right? Of course, when we were in canoe races, we would train by going downriver and then turning around, coming back upstream.
Ooh, yeah, that's tough.
Oh, but you get in shape. And then usually the guy in the front and the bow would set the pace, and the guy in the stern would do most of the steering.
Yep.
So there's a whole technique to it. So if we go,
sorry.
Go ahead, Brad.
No, I was just going to say, I was trying to set you up to tell a story to kind of wrap us up here. We're getting almost to that point, unbelievably already.
Well, the story when we were crossing the log with, we had an architect with us on the trip, and we got to the far end of Moraine Lake and the rushing cold ass creek that was rushing in. It was the direct glacial meltwater, and it had a log going across it. So we're all very carefully walking across the log, and then the architect, he's ahead of me, and I'm out in the middle of the log. And then on the far end where it's on the bank, there was a branch coming up. So he decides when he's going to get off the log, he just decides to grab the branch and hang on to it and jump down. So when he did that, it turned the whole log and threw me down into the rushing river. And that woke me up.
Great story.
But after that, I thought, I'm going to always be careful from now on if I bring architects on any of these road trips.
Yeah.
Well, you got one last Jeremy story?
You got doused.
I probably got multiple Jeremy stories because we hung out and had a lot of adventures together. But I would have to. I don't have any off the top of my head. But yeah, so what we saw here was just a little glimpse into this world of catastrophic geomorphology, which is something, of course, we're going to get really, really into, really dissecting and analyzing all these landforms and trying to understand them. So we'll look at microscale features, mesoscale features, and megascale features. And of course, with the upcoming trip, keep our fingers crossed that late September, we're going to be able to pull this thing off. We're going to go into some of the most spectacular flood landscapes on planet Earth.
Yeah, and we're not planning on postponing, but if it turns out that we have to, it isn't going to be canceled. We're just going to push it back and do it some other time. So it doesn't mean...
Yeah, as soon as we can, basically.
Right, we're going to do it no matter what. So sign up if you want to go. Don't worry that, they might cancel it. No, it's time to be canceled. It would just be postponed if that's what we end up having to do.
Right.
So...
Well, since we were talking about bars, point bars, and scale invariants, can I show 2 more slides?
Absolutely.
Sounds good.
Oh, okay.
I thought we were starting to talk about beers. Like bars? No, okay. You're talking about sandbars.
I do see my hat, though.
Sandbars. Sandbar.
Okay. So here we have, whoops, there we go. I don't know, it leapfrogged over about 5 different
Well, those are all excellent teaser photos. Wow.
Oh yeah, which we're going to be looking at all of these, but damn it, I don't know why I did that. It just jumped from where I had it.
Enjoy the slideshow, folks.
Yeah, sorry guys, damn it. Okay, here we go.
I'm not going to edit that out. I'm going to keep that.
That
Okay.
was awesome.
This is what I'm going for right here.
Okay, there we go.
Okay, current rippled sand deposited on the floodplain of South Fork Peachtree Creek after Hurricane Ivan flooding. That was 2004, right?
Yes.
Yeah. So think about it. You got the creek. The creek is over here just in front of the SUV. You can't see it. It's right on the other side of the vegetation there. But you got this whole park that during this flooding, it was some of the biggest flooding on this creek in decades. So it's rare that the stream actually comes fully up out of its channel and submerges the entire floodplain, which is now a park. But in this case, it did. So the water was roughly right at 2 feet deep, what you see here, that left this current rippled sand. Now, obviously, you could tell that because, for example, there were buildings nearby here, and you could very clearly see the high water line on the buildings themselves, which gave you a measurable scale of the maximum depth. So the wavelength of these was about varied between 2 and 4 inches, and the amplitude, the vertical, anywhere from a half an inch to an inch, right? So you can picture, this is water about 2 feet deep that created this. Now, we were just talking about point bars, and so we're going to look at this, and this is a bar that we will actually be seeing on the trip. This is called West Bar, and it's, 3 miles long. It's probably 200 feet thick of gigantic boulders, but the entire surface is mantled with this huge ripple field. And this is actually an airfield out here. And there's a little 3-story, that white dot is a 3-story building, if that gives you any sense of the scale of this thing. So this is a relict feature. It's a fossil feature. This thing was created, and it's been sitting here for however long since the floodwaters that sculpted and created this and deposited it were finally turned off. And it's interesting here because you can actually see that there was a second huge flood, but smaller by maybe an order of magnitude, because it built this thing out here, which is a much finer grained material and a smaller version of this. But this thing is huge. I mean, it's miles long. So this is a good example of scale invariance. And we already know from high water marks that the water over this was at least 800 feet deep at one time. So, that was pretty much up to the top of if you look over here, the rim of this thing. There's actually, on the bend here of the Columbia River, you'll notice how that this is sharper and steeper, and this is more gentle and gradually sloped, because this is a giant bar right here. You see, it's the same formation on the inside of the meander is where it builds the bar, and on the outside of the meander is where you have a cut bank. And this is actually taking water from multiple sources. There's a gigantic current flow coming down the Columbia from up there near the Plateau area. Up there, what's the name of the plateau up there where Boulder Bar is? Boulder Park.
Waterville Plateau.
Waterville Plateau. That's what I'm trying to say. But it's also carrying water from discharging from Moses Coulee, which is another one of the gigantic erosional features that we're going to be exploring on the September trip. But so that's a great example of scale invariance.
So is the amplitude on these large ripples, is it like 30 feet, 33 feet?
30 to 50 feet.
Okay.
Wavelength, anywhere from 100 up to 300 feet.
Right.
So yeah, it's
Nice.
So you said the other ones were, the water was 2 feet deep, and
Yes.
those ripples amplitude was about an inch. So
About
yeah,
an inch,
you said the water was 800 feet deep in the other one. You divide that by 24, you get 33 feet.
Ah, well, and that's kind of probably the mean of those. They vary.
Yeah,
in height,
the average.
But I think the tallest ones are about 50 feet from the bottom of the trough to the ridge. but most of them are probably between 20 and 30 feet.
Very cool.
Yeah, very cool.
Yeah,
So,
there's a formula in there somewhere.
And then this is taken
Two slides.
in Washington,
Busted.
and this is in Montana.
Yeah.
Same flood.
And Brad's hat's on, so we got to end the show.
Yeah. So we'll leave it there
is
then.
amazing.
And next
That is
week,
amazing.
we're going to talk about some of the last proxy evidence for,
Great intro, though. That's awesome.
yeah. So this
Early
is kind of,
segue
well,
as we steer the tanker, right?
Yeah.
We're one episode in. Yeah, we're getting there. That's what we said. We're going to spend several episodes on the Scablands before we take the trip. So
yeah.
excellent.
And yeah, so this is, I hope people are understanding now that what we're kind of trying to wrap our heads around this whole phenomena. We're looking at the micro and we're looking at the macro.
Yeah.
Yeah. So
I'm really ready to dive into the macro stuff. So I'm glad we got to do this little brief interlude.
well, we're going to
about
come back to
huge
like
boulders.
Lake Hind in that study, the
Yeah.
James Teller study, which I think is
Yeah.
really going to be.
I mean, I'm interested in nanodiamonds too. I think out of all of the proxies, I think the nanodiamonds are the most fascinating. So I'm really ready to get into that as well. But once
Yeah.
we're done with the diamonds, Randall, we're going back to giant floods. Okay.
okay.
Put
I
my
I
foot
promise. Because I love talking about giant floods,
Yes. I know.
sweeping away entire forests, herds of woolly mammoths and mastodons,
Yep.
washing away everything before it, choked with millions of giant icebergs. Because yes, they were filled
Yeah.
with, these floods were filled with huge icebergs, and many of these icebergs were loaded with mega scale debris. So
Wow.
the whole idea of the Scablands trip is to teach people, to the best of my knowledge, and I'm still learning, of course, but to begin to read this language of the landscape and begin to see, because this stuff has been sitting there for 12,000 years, and now we're actually in the position where we can really begin to put the pieces together. So one of the things that we'll do is we'll be looking at aerial photography. We'll be looking at videos. Then we'll be looking at satellite photography to get those various perspectives. And then we'll go out in the field. So we might look at Grand Coulee from the air, from space, and then from the ground being in it. And that's how we will really try to get the full broad spectrum.
All right.
Sounds cool, doesn't it?
It does.
Yeah, can't wait.
Oh, me either, man. Yep. So
2 shows a week.
Brad, any news?
More.
I know you said the website's just maybe will be launched by the time this episode is out, possibly, hopefully. Maybe.
I think we're about a week now, literally, finally.
Yeah.
Literally a
maybe,
week out.
maybe less.
Okay. Well, everybody can get a hold of us, Kosmographia1618 at gmail.com.
If you see Jeremy, send us an email at where's Jeremy?
That's right. We will have a Jeremy sightings thing on the website,
Oh,
maybe.
boy.
yes.
All right. All the links for everything are in the show notes. Thank you guys. That was a
And
great
that's
show, Randall. I really appreciate that.
Yeah,
And,
thanks a lot.
Yeah.
Everyone.
Enjoyed it,
All right.
guys.
Me too.
Next week.
Next week, nanodiamonds.
Yes, sir.
All right.
Goodbye, everybody.
Good night.
Good night, Mike.